Merci Jérémy et merci à vous d'avoir resté ici après 3 jours super chargés. Donc, je ne vais pas faire tout en français, mais je peux commencer au moins. Les noms en jaune sont déjà dans le livret de résumés, mais les noms en lavande, ces personnes ont contribué de donner des idées pour la présentation et son contribution sont très importantes. Donc, je l'ai mis après d'avoir fait le résumé. Et actuellement, le projet que je vais présenter est soutenu par le Conseil de recherche en sciences humaines du Canada à ma collègue Catherine D'Andrea. Et désolée, c'est la fin de français parce que je ne peux pas aller suffisamment vite avec la précision nécessaire. Donc, English. Okay, the Intergovernmental Panel on Climate Change has expressed an interest that spans the natural and social sciences in what were the effects of environmental change on ancient civilizations. Can we learn something from this that might help us deal with the fact that we're about to see some important environmental changes and we have a highly complex series of civilizations that are likely to be affected. For the purposes of this talk, my definition of environment includes climate and what I amorphously describe as land clearing or land cover. And of course, there can be interactions between climate and land cover, but more of interest is how do climate and land cover affect ancient civilizations? How do ancient civilizations affect land cover? This is an extremely contentious, I am finding out, field of study, partly because it does span so many disciplines, everyone guarding their turf, and partly because there's much to understand between the disciplines. Okay, so from the natural sciences standpoint, we're most concerned about, is our global civilization going to crash now? Is it going to collapse? Are we going to lose millions of people due to environmental change? Or, with certain decisions, we could grow, continue more, or we could learn to live sustainably. But people are pointing out from all fields now that, well, we're not gone yet, and many civilizations have collapsed in the past. So we must be resilient somehow. We must be able to come back somehow. What is that? What constitutes that resilience? And what's the relationship between that resilience and all the other problems that could happen between human settlement complexity and changes in environment? Okay, what exactly is the definition of resilience, though? And good luck with that, because I found so many definitions. But in ecology, if you look at ecology textbooks at least, there's a fairly clear definition. If you go through the literature, it gets less clear. But I'm going to take a couple of clear definitions where I can have a null hypothesis. There's no resilience happening. And then some alternatives and see if we can't test the idea of resilience scientifically as applied to humans. Okay, so in ecology, the definition most accepted of resilience is the capacity of a multi-species community or ecosystem to return to its original state after losing biomass to a disturbance. And what I'm going to do is take the 7,000 different definitions of resilience in the social sciences right now and pick one that's most allied with the ecological, most accepted ecological definition, and that's the capacity of the human population, so one species, but we do take into account our socio-natural system as well, to return to a high level of complexity, socio-political and economic complexity, after an environmental perturbation of some sort was a factor in the decline of that particular human population system. Now I'm going to do something weird and give you both the research questions and the answers so far as we know right now to those questions. And then you can see afterwards how I got to those answers, rather than make you wait for the answers till the end. People may be tired, but you do have to look at some of the data too, sorry. What can spatial and temporal variation in water and fire say about the resilience of the Tigray Plateau's ancient civilizations? It's been a question of great interest to us. And note that I changed from the Horn of Africa to the Tigray Plateau. So the Tigray Plateau is in northern Ethiopia and extends into Eritrea, where we cannot work right now. And it was the center for Holocene culture development of the Horn of Africa and possibly of all of sub-Saharan Africa as well. And the answer to that question is going to be, during the wetter periods, they grow immensely in complexity and power and numbers. So they're resilient when it's wet, the peoples. But a question that I'm going to leave sort of for discussion is, should resilience be the goal now, according to our definitions? Do we really want to be resilient? And I'm going to present some ideas that being resilient may mean when the right weather patterns come along, you make the same mistakes. You grow, but then things change a little bit and you crash. Why should the Tigray Plateau of northern Ethiopia be a hotspot for testing these socio-natural resilience hypotheses? And one reason is the peoples over the last few thousand years have had to contend with numerous kinds of environmental change on all kinds of spatial and temporal scales, such as that's where most of sub-Saharan Africa's high mountains are, so that's spatial variation in climate and erosion. It's affected by the northern oscillation of the intertropical convergence zone. It's close to highly active tectonic triple junction, so it's changing in latitude, which can affect things. In terms of human history, it's had at least a couple of very complex civilizations emerge and develop and disappear somehow in complexity at least. So this is only partly part of the story, but the point is the succession of complex polities and their decline provides a good system for testing hypotheses about resilience, and we're going to just focus on two of those. People's decline and fall in settlement patterns. One that I'll call Dimit. How many people have heard of Dimit? No hands. And it's also referred to as, there's an argument about exactly what Dimit is, but it's also referred to as a pre-Aksumite civilization. And more well-known, but still not well-known, is the Aksumite Empire, which was once the fourth most powerful commercial empire in the old world for about 400 years. And also call it the Aksumite. So pre-Aksumite means Dimit, and Aksumite means the Aksumite Empire. What are research goals then? Reconstruct the paleo environments of the entire Holocene and see where the patterns fit in for the timelines of the civilizations per se, examine paleo-environmental records with respect to archaeological records and changes in socio-political, economic complexity of the human cultures. Our first obstacle was just how do we do the paleo-environmental reconstruction? There are no lakes there. But over the years, we've figured out how to get some pretty decent information about both paleo land cover and paleo precipitation. And that's mostly by taking soil samples from gully walls in floodplains. But more recently, we're starting to do cores of reservoir bottoms. I don't know if that's going to be successful or not yet, but it wasn't my idea, and soil pits right next to archaeological sites. And we look at both organic materials and do everything from rustic to fancy and basic soil physical and chemical characteristics to come up with our ideas. Okay, here are some results, oh boy, from gully walls in contexts of unknown archaeological contexts. So that's what we started out with. We worked on gullies that we figured would represent altogether the full Holocene, but we didn't know anything about the archaeological surroundings, and we just had dates from archaeological work in the capitals far away from where we were working. So that's where our first three sites were, and I'm going to focus mostly on, so we did many sections in each site, but I'm going to focus just on one because it represents a timeline of the civilizations. To interpret this mess of multi-proxies, we found that both states of interest, pre-Aksumite or Dimmitt and Aksumite, rose during relatively wet interludes during both of the archaeological phases, and that changes in the percent of all vegetation that was C4 do not reflect changes of climate during the pre-Aksumite or Dimmitt time. So let me repeat that because so many of us are still using delta 13C values to say something about climate. They don't reflect climate. And to get at why involves looking mostly at the hydrogen isotopic composition of land plant derived in alkanoic acids, not alkanes, and delta 13C values. Okay, we had another interesting thing, and okay, so during this time period, you see that the delta D values are going the opposite direction of the delta 13C values, and they should be going in the same direction if climate precipitation is what we're after. So the opposite directions of those two sets of values we hypothesize are because the percent C4 vegetation of all the vegetation was going up due to something to do with land clearing practices and not climate. And other of our analyses kind of support that as well. And in addition, where'd it go? My timeline for Dimmitt when we published this was from the archaeological literature, but Catherine DeAndrea is finding that in the area where we are now, Dimmitt began earlier. So this pattern of land clearing affecting C4 vegetation seems to coincide nicely with the emergence of Dimmitt. And finally, most fire activity encompasses the time of the rise of Dimmitt, is our hypothesis from this particular work. Okay, we're now working in conjunction with archaeologists, so we are picking sites that we know are relevant to some of the Dimmitt and Axumite settlements and doing both geospatial techniques and with the archaeologists and okay, we've added to our arsenal of reconstruction techniques. Okay, what have we just found? This is hot off the press, actually. Huh? C'est tout fini? Okay, this supports what we found before, and this new information on fire history, wow, really supports that there was a lot of burning going on when Dimmitt emerged, and never mind what we're doing in conjunction with the archaeologists. So the society seemed to be resilient when it's wet. The land cover is not so resilient. We're hypothesizing that the Dimmitt peoples really wrecked forests in the area for all times. Should we want to be resilient now? This is an area still prone to famine. Does it mean we're repeating our mistakes when weather permits? Could we find another way? And is the change in fire effects caused by humans? And if so, is it a result of flexible land management or repeating behaviors insofar as is possible, and those behaviors aren't necessarily great for us in the long run? Next.
Danke.